Okay, in this video, we're going to talk about central tendency. We're starting statistics. So we're going to be on statistics for, I think, all of this week. And then we'll move on to the next topic. So specifically, in this video, we're going to talk about central tendency, which this is something that you have probably spent a lot of time talking about in the past. And the four things we're going to talk about today are mean, median, mode, and range. So specifically, let's start off with the mean. Okay, so mean is just the average of your set of data. Specifically, it's the average weighted according to the number of events. Okay, so if you just have, three numbers, you just add up the three numbers and you divide by 3. If you have 10 numbers, you add up the 10 numbers and divide by 10. The weighted average is the idea of if you have, there's a couple different ways you can think about it. One way you can think about it is if you have the same number multiple times, you can think about that as weighted average. Or another thing for weighted averages is usually like your grades in class are weighted, like your exams are weighted more than your daily grades are. And so we're going to talk about both of those situations. So the first example we're going to talk about is if I give you a set of numbers, so find the average or the mean of this set of numbers: 3, 4, 4, 5, 5, 5, 5, 5, 5. Okay, so one way we can do it is, okay, so first of all, the mean, I'm pretty sure you know this, but let's just go ahead and write down what the mean is. The mean is you sum up all the numbers. So that's the sum of all the numbers on top, and the number on bottom is we divide by the total number of values. Okay, so the total number of values is the number on bottom. So for this situation, we could add up all the numbers on top. 3 plus 4 plus 4 plus 5 plus 5 plus 5, 5, 5, 5, divided by how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we add these up, let's see, 5, 10, 15, 20, 25, 30, 38, 41. So this would be 41 divided by 9. And I can do 41 divided by 9 on my calculator. And I would get the number 4.56 if I rounded it off. Okay, so that is just the way to find the mean or the average. Another way you could do this, instead of having to add 5, 5, 5, 5, 5 like that, we have 6 5s and 2 4s. So a different way you could do it is we have 1 3, we have 2 4s. So we're going to do 2 times 4 plus 6 times 5. And you could do 1 times 3 if you wanted to. It doesn't really matter. And now the number I divide by is how many of these do I have? 6 plus 2 plus 1 is 9. Okay, so same thing, I would still get 41 over 9, which is 4.56. And you can double check that if you needed to. Okay, so let's talk about a weighted average in a class. So the example we're going to talk about specifically, this is example number 2. Let's say Jill has an 85 in her class before the final exam. And we're going to say the final exam counts for 25% of her course grade. And the question is, can she end up with an A? Okay, so for this problem, this is a weighted average because it tells us the final exam counts for 25% of her grade in the class. So 75% of her grade in the class is the stuff she already has. So the 85, the grade of 85. It's like all her daily work and tests and everything that she's made before now. She has a total of 85 for her grade for 75% of the class. For the 25% of the class, so 25% of her grade is the final exam grade. We don't know what the final exam grade is, so let's call it X, F, G, like whatever you want to call it. It doesn't really matter. Okay, so I hope that this makes sense so far. 25% of her grade, we don't know because it's the final exam. 75% of her grade is already an 85. So one way you could think about it is like this 25% and 75%, we don't actually know how many grades there were. We don't actually know if there are 10 grades that averaged up to be 85 and one grade is the final exam. Like, we don't really know. A way you could think about it though is, let's pretend like the 75%, you could kind of think about it as 75 of the grades is an 85 and 25 of the grades is I don't know what it is. It's the final exam. Okay. So this is technically 75% and 25% if you wanted to think about it like that, or if you wanted to, it's the same idea. Let's pretend like there's 100 grades in the class. 75 of them are the daily grade part, or the grade before the final exam, which is an 85. 25 of the grades is the final exam grade. Okay, so how many total grades do we have? Well, there's 100 total grades, or 75% plus 25% equals 100%, or you can think about it as 75 grades plus 25 grades is 100 grades total. And our question is, can we get, or can she get an A out of that? Can she get a 90 or higher? Obviously she could probably get higher than a 90, or like an A is higher than a 90, but the lowest she can make would be a 90 to get an A. Okay, so to do this math, we can go ahead and kind of simplify the top a little bit. 75 times 85 is 6,375 plus 25 times X is 25X divided by 100 equals 90. The way that we solve this is we want to get the 100 off the bottom so that we can subtract this number, the 6,375, and then divide by 25. To get the number 100 off the bottom, we have to multiply both sides by it. So we're going to multiply both sides by 100. And when you do that, these hundreds cancel out, and I get 6,375 plus 25X equals 90 times 100 is 9,000. I'm going to subtract the 6,375, and I get 25X equals 2,625. And then I'm going to divide that by 25. And I get X equals 105. So what that tells me is, to get an A in the class of a 90 or grade of a 90 in the class, she has to make 105 on the final exam. So to answer the question, can she make an A in the class? Depends on the final exam. If there's no extra credit on the final exam, then no. But if there's extra credit on the final exam, she could possibly. So I would just write something like no, unless there is extra credit on the final. So something to that extent. Okay, so those are the types of problems you're going to have for the mean. Usually it's just a random set of data. Find the mean of the set of data. And let's talk about the whole purpose of finding the mean. Let's talk about the advantages and the disadvantages of finding the mean. The advantages of finding the mean are, what do you think the advantages are finding the mean? I think about it for a second. What's the benefit, or what's easy about finding the mean? So if you think about it, compared to other measures of central tendency, finding the mean is actually really easy. It's pretty simple. It's pretty quick. So it's very simple and quick. I mean, so simple and quick that like Excel has a function that automatically finds the average of a set of numbers. Pretty simple. And the other benefit is that it uses all the data points in the average. Okay. Okay, so it uses all the data points in the average. Okay, so the disadvantages of the mean. One disadvantage of the mean is that it can be easily skewed. And this is a big deal. Okay, so there is a statistic that at the University of North Carolina, the major that has the highest, how do you say it? Like the highest average salary of their career of people, of alumni that graduate from that university. The major that has the highest is, I have it on my phone right here. Geography is the highest major. If you think about it, it's like, why is the highest, like the biggest salary, if you like take all the alumni and add up all their salaries and divide it to get the average for each like college or whatever, or each degree, the one that has the highest average salary when leaving that university is geography. And you think about like, what kind of jobs do you do with a degree in geography? Like, why wouldn't a science degree be higher, or an engineering degree, or computer science, or something like that? And the reason why is because Michael Jordan graduated from University of, what is it, North Carolina? Yeah, University of North Carolina, and he majored in geography, even though his salary has nothing to do with that. And that's a great example of how it can be skewed so much that all these people, like probably doctors and scientists and all these people that make lots of money, graduate from there, but it can't even compare to Michael Jordan's salary. So that's just a good example of how data can be so easily skewed just by looking at the average of something. I'm gonna do one example. And I'm going to show you kind of how things can be skewed so much. So let's take a sample. We're going to take a sample of 10 people. And this is the salary of those 10 people. Okay, so let's say one of them is $15,000 a year. We have $18,000 a year. We have $35,000 a year. We have $22,000 a year. $675,000 a year, $52,000 a year, $47,000 a year. Let's see, 1, 2, 3, 4, 5, 6, 7. $38,000 a year, $44,000 a year, and $24,000 a year. Okay, if we wanted to find the mean, the average salary here of this random set of 10 people, we would add up all those numbers. So let me add them up. 22, 635, 52, 47, 38, 44, 24. I got 970. If I divide that by 10, it's $97,000 a year. Okay, so we're saying the average salary of this set of people is $90,000, $97,000 per year. Okay, and if you look at that mean of almost $100,000 a year, that doesn't represent any of those people. That surely doesn't represent that person that only makes $15,000 a year, which is like, I think that's below minimum wage technically, or right at minimum wage. It doesn't represent even this person that makes $52,000 a year. It doesn't represent them. It doesn't even represent this person that makes $675,000 a year. So the mean does not represent this set of people very well. It's not a good representation of this set of data because it doesn't represent any of them well. So this is a good example. The reason why this is skewed so much is because of that one huge value where everything else was 50 or below pretty much. Okay, so I hope that you can see how the mean is beneficial. We like the mean when you have a huge set of data. Usually it's a pretty good representation of the set of data. But sometimes if you have one number that's just really messing it all up, that number can totally skew your average. Okay, so the next thing we're going to talk about is the median. The median is the midpoint of the data after it's been ordered. So you have to put it in order first, and then you can find the middle of the data. If there is an odd number of values, your median is just the middle number. If there is an even number of values, then your median is the average of the two middle numbers. Okay, so let's do two problems, one with an odd number of values, the other with an even number of values. Okay, so the first problem, I'm gonna call this number 3, because I think we're on number 3. So for example, if I had 3, 4, 10, 5, 12, let's do that. 1, 2, 3, 4, 5 numbers here. Okay, so first thing I have to do is put it in order. When I put it in order, 3 is my smallest number, then 4, I like to cross them out as I go, then 5, then 10, then 12. Okay, so here's my set of data. Once I order it, my middle number, you can see just by looking at it that the middle number here is 5. If it's a huge set of data and you don't know what the middle number is, you can cross them off one at a time, like 1 from each end, 1 from each end, until you get down to the middle number. So in this case, the median is 5. Okay, let's do another one like that. Number 4, if I have the set of data 3, 4, 4, 5, 20, 20, 22, 23. 1, 2, 3, 4, 5, 6. Okay, so these are already in order. I gave them to you in order, so we do not need to put them in order. So to find the median number, we are finding the middle number here. There are 8 values here, so we're going to have to find the average of the two middle ones. So you can mark them off 1 from each end, 2, 3, and now I have the two middle numbers. So my median is the average of these two numbers. So the median is 5 plus 20 divided by 2, which is 25 divided by 2, which is 12.5, right? Yes. So my median here is 12.5. Okay, so the advantages of the mean. The advantages of the mean are, first of all, that it's not easily skewed, okay? So the big and small values don't affect it. So the really big and really small values do not affect it. And we can see that if we look at this example that we did a minute ago with the salary of the pupil. To find the median, we have to put it in order from least to greatest. So the smallest salary is 15. The next smallest is 22. And then we have 24. Oh, I missed 18. Dang it. So we'll squeeze 18 in there. 24. The next one is 35. The next one is 38. And then we have 44, 47, 52, and 675. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so to find the median here, we're marking them off. So 15, 675, 18, 52, 22, 47, 24, 44. My mean is the average of these two numbers. Okay, so 35 plus 38 divided by 2. That gives us 73 divided by 2, which is 36.5. Okay, so the median salary is $36.5 thousand per year. And if you look at our set of data, that is much more representative of the people in this set. Specifically, like this 36, 35, 24, 44, those are like really close to the middle number. It's not super representative of this 675, but that's what we call an outlier. We will write that down in a minute. But it's much more representative of the other people in the set. Okay, so I hope you can see that this is a better measure of central tendency than the $97,000 per year was. Okay, so an advantage is that it isn't affected or easily skewed by the really, really small or the really, really big numbers. A disadvantage of the mean is, think about what a disadvantage is. Oh, you know what? I wrote mean. This was median. I'm sorry. You probably already saw that. So disadvantage of the median, and this is disadvantage of the median. Okay, so disadvantage of the median is that it takes a little bit of time to put it in order from least to greatest. Okay, so it can be tedious with a really large set of data. Okay, so the last, second to last one we're going to talk about is the mode. So mean, median, mode. The mode is the most frequent value or the value that occurs the most. Okay, it's the most frequent value or the value that occurs the most. Funny story, whenever I was growing up, whenever I was learning mode at first, the definition my teacher told me was it was the value that appears the most. Appears the most is how they said. The value that appears the most. And in my head, that was the one that seems to be the largest, is like the way I took that, appears the most. It was like the one that seems to be the largest. I'm like, that's a weird way to say that, but it's just always the biggest number. So why do we even do this? And so it took me a while to like fix that in my head. So I say that, just be really careful with your words, the way that you describe something, and just make sure you're using words that doesn't have like describe different numbers in the set. Okay, so the most frequent value, the one that occurs the most in your set of data. So let's do a real quick example, and then I want to talk about the mode a little bit, because the mode's the one that I always thought was pointless, but it actually does have a purpose. Okay, so for example, number 5, if we had the same set as before, 3, 4, 4, 5, 20, 20, 22, 23. So which number occurs the most? Well, 4 occurs twice and 20 occurs twice. So this one actually has 2 modes, okay? You can have 1 mode, you can have 2 modes, you can have 3 modes, you can have no modes. It's the one that occurs the most. In this case, I had 2 numbers that occurred twice. If I had 3 4s here, 4 would be my mode, 20 would not be my mode anymore. Okay, so I have 2 modes. I have 4 and 20 are my modes. This is actually called bimodal data. And the reason why it's called bimodal data is because it has 2 modes. Bi means 2. Okay, so with just some random set of data like this, this one kind of actually makes sense. But lots of times the mode is kind of dumb. It's like, or in my head, it seems dumb. It's like, what's the point of this? Who cares if something happened twice or something happened 3 times? Like, that's not a very good measure of central tendency. Measure of central tendency means representing most of the people in the set of data. If something happens twice, that doesn't mean that necessarily it's the best representation of all the people in the data. So that was something that always bothered me, and I wonder if you're in class, I would like kind of ask you, did this bother you also, or did you always wonder what the point of the mode was? Here is what the point of the mode is. The purpose of the mode, the advantage of using the mode is that it is the only measure of central tendency that you can use with qualitative data. Okay, so qualitative data, just a reminder, is data that doesn't have numbers with it. That's like when we did the visual representations, goodness, I can't remember that. When we did all the graphs and stuff, the qualitative data was like, what's your favorite hobby, like sports or reading or books or whatever. So this is the only way to find a measure of central tendency for qualitative data. Okay, so one example, I'll do a couple examples here just to kind of get the hang of it. But one example, I think this is number 6, is if we said for this problem, here are the answers for number 1 on a multiple choice test. And the answers were A, B, A, C, D, C, A, B, A, D. Okay, so that was, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14. 14 students took this test, and on number 1, this is what those 14 students answered. The question would say, what's the average answer here? You wouldn't say average here, because I can't say A plus B plus A plus A plus A. Like, that doesn't make any sense to find an average. I couldn't do a median here either. I couldn't say the median value that people picked here, because the median here, I can't put things in order. A is not like a smaller number than B is, if that makes sense. Even it comes with, like, alphabetically it is, but that's not what we're talking about here. So the only thing that makes sense here to figure out what's the most commonly picked answer on this problem would be the mode. Which one happens the most, okay? And the mode here is, you'll probably see it, A happens 1, 2, 3, 4, 5, 6, 7, 8 times. B is picked 1, 2 times. C is picked 1, 2 times. And D is picked 1, 2 times. Okay, so the mode here is A. So you could talk about the set of data of these 14 students. The most commonly picked answer choice for problem number 1 is answer choice A. Okay, so I hope that helps you see the purpose of the mode. Another example would be if you were given a set of data, if you were like given like a table, and on your table, this is like the people that like to play sports. This is the people that like to read. This is the people that like to shop. This is the people that like to watch TV. Remember how we did that 2 weeks ago, I think it was. And we like say we had a diagram, a frequency distribution here. So let's say 4 do sports. Let's say 6 read. Let's say 7 like to shop, and 10 people like to watch TV. Okay. What is the most common hobby among these set of people? You couldn't really find an average here, because the average here, like if you added up these numbers, like 4 plus 6 plus 7 plus 10 and divided it by 4, that doesn't really make sense, like getting a number answer here. I couldn't put it in order to find a median, because there's not one like that's less than the other, if that makes sense. So the only thing here would be the mode. Which one happens the most? The most people like to watch TV. So the mode here is how you would represent your data. Okay, so I hope that helps you see the whole purpose of the mode. When we have just like a random set of 10 numbers and we find the mean, median, mode, and range, mode lots of times doesn't mean a whole lot for that. But there are some situations that you have to have the mode to be able to even work it out. So I hope that that helps you see the purpose of that. Disadvantages of the mode is sometimes there's no mode, sometimes there's more than one mode. So depending on the situation, that can be helpful or that can be not quite as helpful. Okay, so all of these are measures of central tendency. I keep on saying that. They're used to describe the center of the data, and you use that to predict future data. So if we take a sample of 1,000 20-year-olds and ask them something, and we can find the average, the mean answer, the median answer, and the mode answer, depending on the problem. And then from that, we can use that information to predict the future of, well, since they like to do this, or since this happened with that set of data, then we can use that information to go further with that. One thing that is helpful when you are looking and when you're just given a random statistic of the average salary of a set of 10 people on the road or whatever, if you're given a statistic, a way to determine if it's a good representation of that sample, we already talked about with sample size, like 10 people versus 10 million people. Like you can definitely, 10 million is a really big number. 10 people versus 10,000. How about that? That the sample size, a bigger sample size usually helps balance things out, because there might be some really, really small values, but there might be some really, really big values, and those kind of balance out to give you that center. But also another thing that helps is the range. So that's why we always talk about the range when we talk about mean, median, mode, and range. So the range is the highest value minus the lowest value. Okay, and what the range tells us, it tells us the spread of the data. Okay, so the spread of the data, the reason why I care about the spread of the data is it tells me how much different the numbers in the set of data is. For example, let's go back to our sample of people here. We didn't have a mode for this. This is the reason why I never came back to this for the mode, because we didn't have any repeating values. But for this sample of 10 people, if I wanted to find the range here, the range is the highest number minus the lowest number. So in this case, 675 minus 15, which was 660. So if you saw that the range was 660,000 per year, that would tell you that the highest number minus the lowest number is $660,000. And if my average is 97, like that tells me that there are some way huge different numbers here. If that number right there is 675, let's pretend like that was just 75,000. That would not skew my mean nearly as much. My median wouldn't change, it'd still be the same value. But if that was 75 and I found the range, 75 minus 15 would be $60,000. Okay, so having a range of $60,000, the difference between the lowest and the highest of $60,000 a year isn't that much. Okay, I mean, it is a decent, I'll take $60,000, but in the grand scheme of things, like comparing to this type of situation, it's not nearly as big of a difference. Okay, so when you are talking about range, you want to be aware of a really, really big number means that your numbers are very, very spread out, or at least your lowest and your highest number are very, very spread out. If you have a small range, it means that your numbers are all kind of grouped together about that. So probably an average is a great number, like a mean is a great representation of your central tendency, versus if it was way spread out, an average might be like way over here or way over here instead of being in the middle where most of your data is. Okay, so I hope that that really helps clear up maybe some of the confusion you've had about mean, median, mode, or if nothing else, it takes it to a little bit of a deeper level of the whole purpose of mean, median, mode, and range. The one last thing I wanted to write down is outliers. So an outlier is a value that's really, really high or really, really low compared to your other data values. So it's a value that is very high or low compared to your other data. Okay. We are specifically, like in the next 2 videos, you'll learn how to specifically find what an outlier is. But for now, with mean, median, mode, range, we just need to know that it can skew your data, especially the mean. Okay, so that's where we're going to stop with central tendency. In your next video, we're going to talk about box plots and stem and leaf plots.